So why is blockchain important? Because we live in a world where everything is connected. Almost nobody does things on their own. Every business transaction is connected with a lot of other, it can be partners, suppliers, dealers, all sorts of different kinds of partners, and you have all sorts of relationships between them. You have assets moving on between them. You have processes, and you need someone to manage that for the benefit and for everyone to agree on what's happening. So the way it's usually done today, we all know more or less. We have a business partnership. I have my own little piece of paper. I write down what I think is happening, what I think that I received, or what I think that I transferred. The other part has his own little piece of paper. He doesn't show me his piece of paper. I don't show him, of course, my piece of paper. And eventually, I can be writing one thing. He could be writing something completely different. And we have to live in that kind of a world. That's what kind of blockchain or the shared ledger is supposed to solve or help solve. So the shared ledger is really the blockchain. That's what we're trying to maintain. The whole thing is just to maintain the system of records, the single source of truth that is replicated and shared, in our case, permission, so it's not shared for everyone or anyone who wants to join, but you have to be a member of the specific club in order to join. But once you're a member of the club, you can see it just like anybody else. And it's very clear. So you have the shared ledger. Everybody sees the exact same ledger at the same, more or less at the same time. Everyone can submit their transactions, which are the state changes in that ledger, propose them, and the network has to agree. And once it's agreed, everybody sees it. And there are contracts, what we call the smart contracts, which are the kind of the digital representation of the legal contracts that are done today. And they govern the rules of when those transactions are going to be inserted into the blockchain. So a bit about Hyperledger. I'm mainly talking about one of the projects within Hyperledger, which is the Fabric, which is the one that mostly IBM contributed. So what are the four main kind of legs behind this technology? The first one we kind of mentioned, that's the shared ledger, which is, as we heard already, it's the append-only log transaction, secure, that is replicated among all the members. The second leg is a smart contract. As I said, those are the kind of the rules of the game that govern under what circumstances which transactions are going to be sent to the blockchain. The third one is privacy. So we want to ensure that only the parties that can see a certain transaction or a certain chain at all are allowed to see it, and no information that is not necessary for the transaction is leaked to parties that are not a part of that shouldn't be seeing it. And the important part is the consensus. This is kind of what is the miner's role in Bitcoin, as we heard before. In permission blockchain, it's because of the nature of a permission blockchain, you can do more efficient, more scalable, more throughput, kind of intensive algorithms. So you can have all sorts of consensus mechanisms among the players that ensure that everyone agrees on the transactions that go into the block without having the miners. So eventually, the picture in the middle is what blockchain provides you, instead of each one with their own piece of paper hiding it to the side. So everyone really has their own copy of the shared ledger, and they have the copy also of the smart contracts, which are the rules that govern it all. So it's it kind of levels the playing field in that respect. So what does it buy us? It can save a lot of time. All sorts of financial transactions that today may take days, in this world can take seconds. It removes cost, partly by removing intermediaries that are not necessarily required anymore when using this technology. It reduces risk also, less fraud, less disputes, because everything is there, everything is agreed upon, everything is in the open, and everybody sees the same picture. And it provides you, whoever uses it, with provenance tracking, so you can really track all the history of whatever part that you want in the blockchain, or every asset, if it's asset that you're after, or whatever part of your contract in the blockchain from today all the way until it was born on the blockchain. It's immutable, so unlike Bitcoin, in this flavor of a blockchain, immutability and finality are assured. So it's not that if you have enough processing power, you can, at a later stage, you can kind of change what went into the blockchain. In this case, when a record goes into the blockchain, it's there, it can't be changed, and it will stay there, forever. So basically, this is what it provides. So once a transaction is offered to the blockchain, is validated, is agreed upon by the consensus mechanism of the blockchain, it will go, the effects of the transactions and the effect of the transaction will go into the blockchain and will stay there forever, and everybody will see it. And it's, of course, as we heard already before, the cryptography is at the heart of this, so the whole security of all the processes and all the data structures are cryptographically secure. So a bit going technical, but not too much. How does it look like in Hyperledger Fabric? So this is the current version that is out there. That is more like sort of an alpha version, I would say, just to get people familiar and play around with it. So how did it look like? We have the client. It is the one that can send transactions to the system, and we have the blockchain system itself, which is currently a rather small group of cooperating peers, they are called, and they run between them the consensus algorithm. In this case, it's called PBFT, Practical Byzantine Fault Tolerant Algorithm. That is, as its name implies, it resilient to Byzantine behaviors of some of the nodes. So a client issues a transaction, it looks up one of the peers, sends the transaction to that peer. The transaction proposal gets spread around all the peers. They do their algorithm, they validate it, that the transaction is okay. They agree on the order, and then each one of them actually executes the transaction and puts the transaction into the log, into the blockchain, and the effects of the transaction in what's called the world state, and everybody is happy. And we have membership services which issue certificates to the permissioned network. So this has been out for a couple of months, and we learned a lot out of it. Mostly we learned what needs to be improved, and one of the first things that needs to be improved is really the scalability aspects, both in the number of participants and in the transaction throughput, because these kinds of algorithms do not scale very, very well, so something needed to be done there. Better support for confidentiality, because in this structure, all the peers see all the transactions, see all the smart contracts, and they can see everything. And we know that some of the large enterprises that want to use the blockchain do need more fine-grained levels of confidentiality. There were issues with non-deterministic transactions. So that evolved to to the next version of the architecture, which is going to be released in March, towards the end of March. So in here, we still have the good old client SDK and the membership services that provides all the certificates. But now we have a much larger set of peers that can participate, and they don't have the same role for every transaction. So the client first wants to issue a transaction. He sends it, he knows a subset of all the peers, which are called the endorser peers, and he sends the transactions first to them. They are the ones who are in charge of accepting or not accepting the transaction to be executed on the blockchain. And moreover, they are the only ones that actually execute or do a simulation of the execution of the transaction. So they do the execution. They prepare what's called the read set and write set, which is all the version numbers of the parameters that they actually read while executing this transaction. And they send all the information back to the client SDK, all that, including all the read set and the write set. And if they're in favor of allowing the transaction or no. And once a transaction is accepted by the endorsers, it sends to a separate set of peers that all they have to do is just agree on the order. So that can go really fast. It's a consensus just agreeing on the order. And once the order has been agreed upon, they submit, make it available to all the peers, the large amount of peers. And in that case, if all the prerequisites of the version numbers of before are still valid, then all of them, they don't have to execute the transaction. They just apply the changes implied by the information that was sent to them. So this is the kind of very high level, the architecture of what is going to be the version 1 of Fabric Hyperledger that is expected to be GA'd in the end of March, so in a couple of months. So that's more or less a bit about the technology, and a bit about use cases. So there are, as you saw earlier, there are a large number of use cases. There's a huge interest from different parts of different industries. Some of them just because they hear about it and they want to understand what it is. Some they hear about it and they're afraid of it, and some that actually begin to see the value. So it starts from easy, let's say easy to understand, of just translating, making current contracts more efficient, and making them more automatic, more digital, rather than what we have today. And that's really taking kind of existing business contracts, move them to what's called smart contracts, and have them execute automatically on the blockchain. So this is a kind of a first step of using a blockchain to enhance really the collaboration between partners. If we go to a kind of a typical, also easy to understand supply chain scenario, so a lot of people they want to achieve is traceability. Traceability in a lot of in different dimensions. Both traceability that the end user can kind of trace back and ensure that he's getting quality products or he's getting what he thinks he's getting. Both traceability and visibility between collaborating members of the supply chain of what the current state of the contract is, where it is. So let's see in a very simple example, we have a short supply chain. We have the producer on the one hand, it's a fishing company. They have a boat, goes out to fish, comes early in the morning back into the bay with a bunch of fish. We have the transportation company that they need to take the fish from the harbor and distribute it to the supermarkets, to the retailers. The retailers, they have to kind of ensure that that they are satisfied with the quality of what they're getting. And then there's the end user that also wants to be assured what he or what she is actually getting. And above or on the side, however you want to look at it, there's the regulations. So the regulations that want to ensure also that of what's going on. So we'll go quickly. The fish company comes back, puts the fish in a box. You can put a QR code on it, on the box, scan it, and it goes into the blockchain. It shipped to the truck or whoever, the shipping company. They scan the QR code as well. The ownership moves from the fishing company to the shipping company. And we also have automatic tracking of location of the truck, and also we know that fish, they need to be at a certain temperature, so we have an other kind of temperature device in there that also keeps track of the temperature, and that way we can see where it is, we can see that the temperature is in the range that we're happy with, and we can report it eventually all the way back. The supermarket gets it. They can scan it once again. They can see all the process, so they can see that it's fish that is from today that has been transported. The transport took not a long time. That the temperature was within bounds in all the time, so they are happy that they get fresh and good fish. And the same thing, whoever actually comes to the supermarket to buy can get reassured that of exactly what it is they're getting. So, and the regulators and the authorities. Since we're really running out of time, I just say a couple of words about what Hyperledger is, and I'll finish with that. So. Hyperledger is really, it's an open source blockchain platform project that is hosted by the Linux Foundation. IBM was one of the main founders and still one of the main contributors of the Fabric component in it. And the main idea is to create an open source permissioned platform for blockchain, to be used mostly by enterprises. So it is quite big and growing, and I'll finish with that, which is more kind of the official kind of point of view. So really talking about a more efficient, secure shared ledger technology. Of course, for IBM, Bitcoin is a word that shouldn't be kind of spoken in the same sentence as Hyperledger, as blockchain. It's a lot about building it in the open, building it for enterprises, and so it's really that part which is going after the enterprise market, which is interesting for IBM. So that's why all this interest, and this is why this is the kind of the niche if it is a niche within blockchain that IBM really is focusing on. So.
Square the circle between confidentiality and asset transfer? Because if not every node sees every transaction, then there isn't on the consensus level of the network, not every node knows that an asset has changed hands. How do you view that conflict?
The one thing that I didn't show here in the next.
Maybe you can repeat the question because they might not have heard in the back.
So the question is really about how there is a tension between confidentiality and between what we saw here of the network actually being aware of all the transactions that are happening. So what I didn't show here in the next architecture for simplicity is you would like the name. It's called multi-chain. So basically, the first version of it was really to try and do it with kind of sending the cryptographic keys only to the relevant parties, so they can only decipher it, and the other ones just see blobs. But that wasn't good enough for some of the customers. So the latest evolution is really to support multi-chains that are completely disjoint, and so the transactions, the consensus can still be the same consensus. They can still see it all, even though they don't necessarily see anything but the IDs of the transactions, but the chains will be only between a subset of the participants. So the system will support multi chains within the same infrastructure.
Thank you.